Dimmi. Qualcuno vuole no, era solo il suono della registrazione. Allora dicevo, tanto per cominciare una pubblicità, se qualcuno di voi volesse partecipare al corso sulla storia dei computer, ho messo qui lì in chat il link di comunque ho trovato tra i corsi del dottorato in ingegneria dell'informazione. Viene almeno il dottorato in ingegneria dell'informazione e quello di fisica sono d'accordo nel considerarlo soft skills e saranno 12 ore, quindi sarà un bel po' di roba. Quindi guardate un po', insomma, fate voi. Ehm, Va bene, allora, se non avete, altri suggerimenti, vi posso proporre, la modalità del corso è come questo qui, c'è anche in presenza, sì, tutte e 2, in presenza a Santa Marta per chi volesse partecipare in presenza e se no online con registrazione come al solito. Va bene, allora quindi vi propongo il seguente problema, anzi vediamo se riesco a condividere anche lo schermo che ci posso disegnare sopra. Oggi sono a casa perché poi dopo c'è una riunioni varie. Allora, guardiamo se riuscissi a aggiungere e a condividere lo schermo dell'iPad. Vabbè, comunque, in ogni caso, allora l'idea è la seguente: di aggiungere un extend display, eccolo qua, vediamo un po' se ce la faccio. Ok, vediamo se funziona. Da quale parte l'ho messo? Dalla parte sbagliata. Allora, quindi, non so se avete mai giocato alla corsa delle macchinine alle elementari. Allora, funziona così, vediamo se riesco a farvelo vedere. Prendiamo tipo PowerPoint, tanto per far vedere qualcosa. Così poi dopo ve la allego. Allora condivido lo schermo peccato che non mi veda sì, questo qui. Okay? Va bene, proviamo a farlo a scrivere su PowerPoint. Peccato che questo qui non mi prenda il mouse. Scusate, ma io così non vedo più nulla. Allora slideshow, setup show, window, okay, così se ne sta tutto lì buono. Okay. Okay. Peccato che però non prenda la penna. Allora quindi è tutto inutile. Va bene, lo farò a mano. Allora, quindi l'idea è la seguente: voi disegnate un circuito delle macchinine, meglio sarebbe farlo su un foglio quadrettato, d'accordo? Quindi questo qui è il nostro circuito, questa qui è la linea di partenza e poi qua andremo a piazzare una macchinina. Diciamo l'idea facciamo intanto a regime, supponiamo che siamo qua e abbiamo fatto una certa mossa, quindi siamo andati da qui a qui, quindi con una certa velocità. L'idea è che la volta seguente bisogna rifare la stessa mossa, più o meno una certa variazione, che su un foglio quadrettato sono gli 8 vicini, quindi uno può andare in uno di questi e tipicamente per esempio va qui. Dopodiché deve rifare la stessa mossa più eventualmente una variazione di 1 nelle 4 direzioni, quindi che ne so, può andare qui e così via. E quindi come vedete in questa maniera si riesce a dare l'idea dell'inerzia, quindi che uno non può sterzare da 0, ma chiaramente la velocità varia di una certa accelerazione che è legata, beh, all'aderenza delle ruote, cose succede, non stiamo a complicarsi, anche se uno potrebbe mettere, per esempio, una pozza d'acqua in cui l'accelerazione cambia e così via. Ritorna come è fatto il problema? Quindi l'idea è, che la velocità v come vettore al tempo t+1, scusate devo scrivere col mouse, è uguale alla velocità al tempo t più, una accelerazione per un delta t, che diciamo un delta v, via facciamo. Delta v, no, con delta v, delta Vx e delta Vy è, diciamo, limitato. Ora poi decidiamo se vogliamo farla, possiamo farla sia, come si fa con i quadretti, sia si può farla continuo. Ah, scusami, sorry Zara, I forgot that, I was, I had to speak in English. So the idea is the following: let us model, a circuit, car racing circuit. This is the start line. We start with the velocity equal to 0. And the rule is that you can have at most a certain variation of velocity of, say, where each component, all the modulus, if you want to have a continuous approach, the modulus is limited by 1, for instance. Say delta V modulus is less or equal 1. And that's all. So essentially we have to drive the system trying to complete the run in a small time. And so we start with velocity 0. So the first we have to accelerate, then we have to be careful not to accelerate too much, otherwise we go outside our circuit. So we can also steer and so on. This is essentially a game. Clearly, then we can convert this in several other ways. For instance, I don't know if you remember the game Asteroids, in which you had asteroids coming towards you, and you had to destroy them, disintegrating. In this case, we don't fire, we have just to drive a car. So if you agree, we can try to develop this scheme. And okay, Lorenzo. So let me switch screen so that I share another screen, this one, where I have my NetLogo. So first of all, we have to draw the circuit. This can be done in several ways, but essentially we can use the fact that it is possible to save this view, this part, the world, as an image. But you can also load an image into this into the patches that compose your word. Clearly, I don't remember the name of the function, but we can look into the dictionary and see that patch or maybe it is word. It is import drawing. So you can produce some image, and this is imported and it is drawn below. But this is not what I want, because you can import a drawing, but it cannot be used by my patches. Instead, I want to import these p colors so that now I can draw the circuit using, for instance, I don't know, PowerPoint or any drawing software. And then we import the colors into our NetLogo so that we can have different circuits. Okay, so let's start with PowerPoint. We'll keep. So no. Let's start drawing some circuit. So for instance, I can insert some shape, like I don't remember which. This is scribble, arc, curve. Okay, so let's suppose this is our circuit. Then I say I don't want to the fill. So I don't remember where, because I never use PowerPoint actually. Okay, where is picture shapes? No, where is the fill? Here. And the outline should be, say, so fill, no fill, outline, say, very, very thick, because this becomes our circuit. Or we can let's do another way. We duplicate this and we fill the space between these two with some color. So okay, I can set the background of my slide black, say. This is in white, and fill in say white, and this in this small. This can be in background. Okay, this one in black again, and black. Okay, so suppose this is our starting point. We can also draw, say, some starting line here. I don't know if it is good to do. Well, maybe not here. We can do it in NetLogo. So let's enlarge a bit this. I hope this is good. Okay, so we can export this slide as say some racing, say, and not here, say here. Then I'll put them. Okay, I can work directly on the shared directory. Okay, so I can also save this presentation so that you can edit. And then let's try to lower this, and then we can say change the shape. But for the moment, let me save this in the same shared document here. So racing. Okay, so let's start with the classical setup button, and then to set up clear all as usual, and then we can import pcolors, and then we have the possibility of putting a choice of a file, if I remember how should be input output. So should be user file. That I don't know if it is working. Let's try. So set up, then I can choose the circuit, and clearly this depends on the resolution of my grid. So let's say increase and make it more rectangular. So max pixcore say 64, and here 48, and clearly with a smaller patch size, maybe larger. Then let's try again. Okay, this is more similar to what we would like to do. Maybe we can also increase 128 and I don't know, 64 or maybe okay, 80. Let's try now with smaller patch size. Okay, so okay, this is more similar to what we would like to do. Okay, then we need also a car, so we can draw a car, say turtle shape set. So maybe you have this car, but it is preferable to have a car seen from above. So I don't think we have an already made car here, so we have to draw. Let's new F1, and then we need say the body of our car. So let's draw something like this, and then we add some so this is gray. This is what will change, the color that will change. Then we can add a pair of wheel, say here and here, and say larger here. And then clearly we should also add some other element. I don't know, we can put something here just to simulate some other element. I don't know. I'm not a fan of of Formula One. So this is a rather schematic, but I think it can go. Maybe we can add some other element just here. Say this is in black, this is in black. Okay, so now with black it is not very good, but I think it can be seen on the white screen. Okay. So, and then so with the setup we can also create a turtle one, set the color red, set the shape F1, set set XY, set heading 90, that should be horizontal, set XY, say X0 and Y, I don't know, minus 40, and then I don't know, set, let's see what happens. So okay, I have to close this. Okay, then I think that we should import racing.png directly, otherwise any times it asks the user file. Okay, and then so it is so small that maybe we can set the size I don't know, 5, still maybe too small, 8. Okay. Then maybe the starting is 10. Okay, and then we can also draw some line. So ask, not here. Say here, ask patches with px core equal to 10 and py core less than minus 40 and py core greater than I don't know, say from minus I don't know, minus 30, greater than greater than less than minus 30 and greater than minus I don't know, 80. Set p color green, then we adjust. Okay, too much, but okay, we can then 35, 70, okay, maybe 33 and 68, 65. Okay, and other people wanting to participate, I think. Anna, okay. So essentially, this is for the beginning our tool. Then we started with buttons, and maybe then we switch to mouse. So the idea is that we can say have a button for forward or to gauge, to speed. Then we may decide to have, I don't know, this, we have to use letters, so we have to decide if you are right hand or left hand. We can use some action key, which is, for instance, I, J, K, L. So this is for a race. Then we may have a button for brake, action key K, and then we can have a button for going left, say J, go left, or turn left. And then another one to turn right, say this is L. Okay, so this is more or less our, we can also move this here and say make more space. So, okay. Then clearly each car has the pointing is say heading, and so it is okay. I think we have to add some velocity. So turtles own v. This is the modulus of a velocity, and so then clearly we have also you need also a button for go forever. So let's start with say speed. To speed or speed up. Let's say speed up is set v plus something. So clearly we can make a slider here, say delta v. Then we can adjust, say maximum, I don't know, 5. V plus delta v, quite simple. Then we can break, say equal, to break minus. Then to turn or steer left, set heading minus I don't know, max angle, minus, let's say -1 degree, and then we see what happens. To turn right, +1. Okay, so we did almost all, and then to go. Now the idea is to use a certain so to move essentially forward, to go ask. Okay, no, this clearly I have to, all this I have to address to my car. So then we can try to add more cars if you want to make a real racing. And then maybe next lesson we can try to convert this into a multiplayer game. This is not so easy, but so we say ask one of, then we shall convert this into a different set of of cars. Or say, let's ask turtle, let's say turtle 0 for the moment. Then we have to repeat this for all of them. Okay, then we can make the same for the other player. Then maybe we can convert this into speed up 1, turn left 1, turn right 1. But for the moment, let's use just a single car. To go, ask turtles forward something. Say forward 1, forward v, which is the velocity. But this has the problem that if I forward the v, I can cut, for instance, if I have a great velocity, I can cut out a piece of my off circuit without slowing down. So then we have to convert this into a cycle. But for the moment, let's see what happens. Forward if p color equal not equal white, say user message out of circuit or UR. And then stop. Okay, and let's see if this is working. So to go, okay, because it is green. So let's say here it is black. Okay, so to go, I can speed up, but it is, as expected, it is too much. So we have to reduce this delta V by some large factor. Say, let's define here globals factor. Say set factor 1 minus 10, and then this is maybe too much. Let me see how much is inspected turtle 0. So it is moving, but so slowly that we have to reduce the factor. You see the velocity is something, but it is extremely low. So let's say let's change the factor by times. Setup, go. Okay. Then clearly, now I shall try to, okay, halt, to go using letters. So in this case, it is much simpler to, it's not so easy to turn left. We have maybe to increase the turning left and right by, say, 5. Oops. Okay, clearly now we have to say to add some other element. So this is the main idea, and are there any questions? What do you want to add to this game for the moment? Where do we have to register online? Ask to in the computer history of computer. In the first lesson, I shall communicate the form for registering. And okay, so what do you suggest to add to this game or to similar games? Nothing, no suggestions?
Maybe we can add some obstacle. I don't know, something that we should avoid during the run.
Hmm. Okay, so this okay, this could be an option clearly, and another option could be trying to program this car. Try to add some element. For instance, clearly one possibility is to add some neural network and train the car, but it is a bit beyond what we can do. But I would like to so we can also add obstacle then. But for the moment, let's try to add something so that the car can try to to steer and to brake or speed up by themselves. So the idea is to use some other element that turtles can have. So it can watch ahead. So essentially, it can have an idea of what is ahead of this car at a certain angle with respect to the heading and at a certain distance. So the idea can be we can ask the car to look ahead at a certain distance according to their velocity, for instance. And if there is something on black on the left, it can turn right. If it is something on the right, it can turn left. If there is nothing, it can increase the speed. If both left and right and maybe ahead are occupied, it can brake. Something like this. So let's try to implement this idea. Do you agree that this is can be an interesting how do you say way of say implementing some kind of say artificial intelligence in some sense. So this is say something look ahead angle. So we can then practice. So it look not written like this. In this way, it can say look at a certain angle. Then we can make this depend on the velocity or not. It should depend on the velocity. And then we also may add some look ahead factor, which is something that multiplies or divides the velocity so that it gives you the cone essentially, no? Over which it can look at. And okay, so let's try to write down something which is automatic. Go to auto, ask turtles, and then we can say have different cars, maybe with different strategies, and see what happens. This could be an idea, no? So ask turtles, let's say if patch, if color, p color of patch ahead, patch left and ahead, or patch right and ahead, patch right and ahead of a certain angle. So look ahead angle, look ahead angle, oops, and look ahead, look ahead factor times v. So if the color of this patch equal black, so we have, so say let's define some variables. Let obstacle left, obstacle left this. In fact, the fact that we have a patch at a certain distance and at a certain angle equal to black. Then we can obstacle right, the angle is multiplied by -1. So so if say obstacle left, say let's put if else. So if else can take several cases, but in this case we have to put all within a pair of parentheses. So if else obstacle left and obstacle right, so if both are occupied, set v minus s break, so break. We have to convert okay, we can do this, but we have to convert this break. Okay, so let's just copy this for the moment. So this is one case. If else obstacle left and not obstacle right, just to be explicit, set, let's say turn right, so this one. And then all the other cases, so not obstacle left and obstacle right, turn like this, else, okay, metti, else set v plus this. Okay, and then we can, as before, forward v, and if p color equal to black, okay. Stop. I don't know why stop is not working, but it should end the simulation. But in any case, let me see. Obstacle. Check. Obstacle. Check. If else, expect a true false. Obstacle left and obstacle right. A true false, a command block, and a this is the last command block. Okay. Well, let's see what happens. Clearly, I need the button, say, auto. Okay, something. Maybe the look ahead factor is too much. It is retracing. Let's say, let's see. Look ahead angle. This is not, and distance. Look ahead factor times v. Okay, so let use a label just to see what happens. Set label, say both. Set label left. Set label right, and then set label none, so that we can have idea what he is seeing. Maybe we can set the label size, set label size. How is the label? Set label should be, there should be a size for the label. Label, label color, pen mode. I don't why I don't see. Maybe it is too. Well, I don't know if I don't see anything, or it is say set label color, say green, to see if it is just invisible, too small. Something wrong. Okay. I don't see it seems to be white instead of label color is white. I don't know why. So 9.9 is essentially white. I don't know. Label color purple. I say the color swatches set, let's say 72. Okay, so essentially, is it always switching between both and none? If ask turtles. So I don't obstacle left and obstacle right. I don't understand why. Maybe this is too much. So if I put this at 0, I don't know why it is always probably because this else is not working. Okay, let's make it and not obstacle right, otherwise it does nothing. This was not the problem, and so clearly an else should work in the right way. Obstacle left. So if I put a look ahead factor, nothing. Continue. No, something is broken. I don't know exactly why. Okay, let me try to find what is looking at this card. So ask turtle 0, and so ask patch right, and so this one patch right and this is set p color, say green. Okay, too much. Ask patch, look ahead factor. Should have a double green, no? Okay. Okay, so the problem is this one. Okay, this is 0 maybe. So if I increase this, I don't see any patch which is green. let's say that I can so look ahead factor, so let show this is patch 10, so title 0 is in position 10, so essentially it is behind it, it is below it, so in this case because v is equal to 0. Okay, so let's try to have v equal to 5. In this case it is something, and so okay, now with this factor and v equal to 5 he is looking at this. And so I don't understand. So if I ask auto, okay, so let's try with auto, not forever. So auto, this is working now. Should okay, so let me put some angle. So I don't know why in this case where it should have a velocity equal to 0. So it should look at the same patch. So color of show color, ask that show color of patch right of this and this. A patch can access a turtle or link variable without let me ask this. I don't understand why I say ask patch look show okay, now I understand. It is p color, which okay, 50. So the problem probably was this one, that I had to put parentheses here. Maybe this was the problem. Let me see. Auto, none. Okay, so it should increase. Okay, so the problem was just parentheses. So it should increase the velocity, and at a certain point it should start moving. Okay, too much. Let's start again. Setup. Let's put look ahead factor greater so that we can speed up things. And then let's see what is happening. So you may understand that it is not so easy to make things that are so working by themselves. So we should remove the other factor, otherwise we have to. So let's say to try to change the velocity directly. 1. Okay, and then auto. So it is going on. The problem is that he's not. Okay. So the problem is that it is breaking now but never turning left because it sees both and okay. In any case, this is more or less there. Clearly, we have to calibrate a bit these factors in order to make things work better. But this is essentially an idea to clearly not to make just the racing of cars, but for instance, to program, I don't know, ants to go on and forage and look for food and things like this. Mm? So I'll try to refine this in the next days, just not to let you spend too much time watching me trying to optimize the factors. But maybe this could be an idea to develop to make, say, kind of agents that goes so looking at what is in front of them. Okay, so let's pass to another example if you want, and let's try, for instance, to have a look at the 3D version of NetLogo. Just to have something different so we can take the 3D version which you should have with oops with your NetLogo. Okay, so the 3D version is slightly different. You still have this code, but the world is isolated. And clearly, in this new version, patches have 3 coordinates, not only px core, py core, but also pz core. And okay, we can, for instance, try to do something similar to what we did in 2 dimensions by making a kind of, say, I don't know, particles that randomly move, and if they stick, they stay together. So essentially, we are making a kind of diffusion limited aggregation, but in 3D, so that we can have a look at what is growing in 3 dimensions. So again, the interface is similar. We have to start with the sun setup, and to set up we can then again clear all, ask patch 000, I don't know, set p color white. So this is a very simple I don't know. This is wrong. Okay. Setup. Okay, so in this case we just have one particle. Then we can also create a certain number of turtles. Let's put some slider and turtles. Okay, So create turtles and turtles. So no, and turtles without this. And then when I create them, I can change the shape. Again, we have the shape set. Actually, turtles have just a two-dimensional shape, not a three-dimensional one. So say set shape circle, and in this case, no, I don't understand. Where are the turtles? Set color green. Something is not. Okay. That every turtle is created in the middle, so we don't see them because of this. And then set x, y, z, random x core, random y core, random z core. Random. Okay, so this could be one possibility. This is okay. Or we can say try to create them near the border, and then let them wander. I don't know, so that if they move and go outside, they are repositioned in some places, or simply they cannot move. Okay, let's use this simpler approach. So to go, clearly here I need some go, whatever. To go, we can first of all ask turtles with any patches. Okay, I can ask turtles which, or say with any neighbors with p color equal white. So if a turtle has any neighbor, now there are we have to decide if we want to have just the 6 first neighbors or the 25. No, then how many are 27 neighbors? So 27 neighbors, first and second neighbors, or neighbors 6, which is the 6. So I think that it is better to use neighbor 6, otherwise we don't understand very much what is there. So if they have some neighbors which is white, ask patch here. Patch here is the patch below the turtle. Set p color white, and then to reposition in a random place. So maybe this can be made in a procedure to reposition like this. And maybe we can ask them to always stay in on integer coordinates. The difference between random X core and random PX core is that random X core is some random coordinates between the minimum and the maximum, but can be continuous, is continuous. While random PX core is an integer from the minimum and the maximum of the patches. Okay, so when then reposition. And then ask patches, simply say move to one of neighbors 6. And this is should be if it is ask turtles, not patches. Turtles. Okay, so setup and okay, it is not really. Maybe we can start and instead of reposition, we can ask them to die just to see what happens with a certain number of turtles, which say essentially stops there. So if I have more turtles, they grow for a longer time, and then finally all of them are, say, absorbed. Okay, what do you think? Do you have some variation in mind? Clearly, you could try to, say, set up some Tetris and play with this setup, which is not so easy. Or let me save also this one in your shared. I don't remember which one is this one. Let's say DLA 3D. Okay, other questions or suggestions? Otherwise, I think we can say move to some less more boring things, say, to examine a bit more in deep the language of NetLogo. Let me, I prepared okay, if let me see which one is the latest version. This one, this, okay, I think this is, okay, so in this code then we shall examine the code, but essentially it start, so it is a way I can put it in the shared directory as usual. So essentially this is a script to examine what NetLogo, what are the operators. I don't know if I put all of them here, but many of them, yes. what operators do to lists. Some of them take 2 arguments, and for this there are 2. Otherwise, or a number and a list. Some of them just take a list. So, for instance, this is a list. Clearly, you can replace this with some other things like a string or another list, like at the beginning. Okay, so let's examine a bit this. So, but first, list clearly returns the list, which is this one. You can use it in this way. Just dropping the first item, but last drops the last item. This test if a list has at least one element or not. So this is clearly an empty list. The brackets are put automatically by my script, so here you don't have to put anything. So this is true all contents, including some empty string or some empty list, gives false. Okay, filter is interesting because it can returns you the string only with elements that obeys some test. So when there are these manipulation of list with arguments, and generally they are in the form of an anonymous function, and an anonymous function you can declare here whichever name you want for your local variable, and this is assigned, each element of the list is assigned to this local variable, and then if this report returns true, this is kept, otherwise it is removed. So, for instance, here actually this is redundant because it is this is just you can just ask if it is a number or not, for instance, or is number and y, I don't know, greater than 5, y, small y. And clearly, it is, as always, the end, it is, first it is evaluated this. If this is true, then also this is evaluated. Otherwise, only this one is evaluated. So you don't need to be concerned to the fact that y could be a string, because this is evaluated first. So if it is a number and this number is greater than 5, you keep the element. Otherwise, it is discarded. So if you put 1, also 3, 5, 6, and 9 are included, and so you can play. Then first is the opposite of but first, so it only returns the first element. It can be again a string or a number or whatever you want, or another list. And okay, then fput is the opposite of but first, in the sense that instead of returning a list without so with some element removed, it adds something to the list. But remember that in NetLogo all variables essentially are immutable. So if you put fput puts yes this b in front of this list, but the original list is not changed. It may be discarded, but not changed. So you cannot say write just fput. You have to say to see something. Let b f or let my list fput b my list. In this case, you take the so let me try to write down here. No, I have to use this like as a test. So to test, let my list, I don't know, 1, 2, 3, 4. Then I have to say set my list fput b my list, show my list. So let me let me show word show my list. Okay, this is enough. So show my list here, show my list after, and then I don't know, show something like this. So if I now execute this, you see my list was first this one, then it is this, but actually they are not the same in some sense. My list, this my list was used, and then since this has the same name of this, this was discarded, and this is a new object with the same name but different. So yeah, I cannot simply write this because this gives me an error. I cannot manipulate lists or any other object. Okay, so let's go on. Item is the same, so not the same, it is not. Item, say 3 of this list is the third item. Let's remember that items start from 0, so the third item, this one, and so 0, 1, 2, 3. Then last, you can imagine, is gives you the last item of a list. Length gives you the length of the list clearly as the number of items. So for instance, this is one item, 2, 3, 4, 5, 6, and 7. Then lput is the opposite of item that puts something on a certain position of a list, but again it returns the new list, so it does not alter the old list, it returns the new list. So you have to assign this to some other list or to the same list, but not simply manipulating. Map is interesting because it is a real powerful operator that applies this function to each element of a list and returns, for instance, in this case, the square of all elements of the list. But I can say, for instance, just apply some things. So in this case, for instance, this simply replaces, actually takes a list, and for each element it is replaced with a random number. So this is executed again and again and again. For this is why it is still changing. It can be also applied to more than one list, the map. Let me try to write down here to test one. So let my list say 1, 2, 3. Let my other list say 4, 5, and 6. And then let result list. Now I want to map something to my list and to my other list. In order to, since it has more argument, I have to wrap everything in same parentheses. Here now I give it 2 arguments and what to do with these 2 arguments. For instance, x plus y. So show my list, show my other list, show result list. And then map x, y, x plus y, expected something that I did not expect. Let me map. Map this is for, you can also do this with the 3 lists. So I don't understand exactly what is wrong here. Map x, let result list map xy in x plus y. Maybe x is already used. A, b, a plus b. No. Okay. Clear. We don't have this second pair of parentheses. So test 1, now it is like performing a vectorial sum of 2 lists. So I am applying this to 2 lists. Clearly, I can define a function to do this. Okay, then other simple elements. Max of a list is the maximum of the list. Member tests if something, which can be a list or a string or something, is part of a list. In this case, yes, true, because 1, 2 appears here. And so if I put here 8, it is again true, while 9, it is false because it is not a member of the list. Min is the same as max. And Okay, modes is interesting because it gives you the item that appear more often in the list. So for instance, if I add here some other 7, now it is 7, which is more frequent. If I have um, if I have, for instance, in this case, you can see that C is appearing twice, but also 5 is appearing twice, and also the list 1, 2 is appearing twice. So modes gives you the list of the items that appear more often in your list. I never use the modes, but because probably I'm not very well skilled in working with list. And number is also quite interesting because every time it is executed, clearly here it is executed at each every few seconds. It takes a certain number randomly of elements of the list. And this is also a way of building a list. So for instance, you can okay, building no, we shall see then a way of building a list on the fly. And then okay, position is a way of looking for the position, the first position, because if I put here another 7, it doesn't change. The first position of a given item inside the list. Then one of is the same as n of with 1. So 1 of this is the same as n of with a 1, like this. This is essentially the same. And reduce is another interesting operator. It is in some sense like map, but it does the following things. It takes the first 2 elements and applies the map. Then it takes the result of these 2 and the third and applies the map. So in this case, for instance, I end up making the multiplication of these numbers. And clearly, if I put the plus here, I have the sum of the numbers. If I don't know, multiply, say, 5, I don't know. I can, for instance, I can build up this as a number. So I can multiply this by 10 and then sum this one, multiply by 10, and then clearly I take the first 2, I multiply 1 by 10, I add 2, so I have 12. Then I multiply 1, 2 by 2 by 10, 120, and add 3, and I have 123, and so on. So I convert this list essentially into a base 10 number. Clearly, one can do whatever one wants. Generally, I use just to sum, but in this case, you can just, I haven't put it here, but you can just use the sum. Sum operator sums all the items in a list. It is like reduce with the plus. And then remove essentially clearly you can understand, remove an element from a list. If the element is not present, it is not, the list is not changed. If the element is present, the list is changed. Remove duplicate is also interesting because remove duplicates. For instance, here I have the 2 which is duplicated, and so here only the first one is left, and also the sublist 4, 5 is duplicated, and so here only the first is left. Remove item, it is the opposite of insert, where was it? This. So this is for getting the item. This is for removing the item, and then there is also a way of inserting an item in a certain position in a list that I don't have listed here. And so remember again that items starts with 0, and reverse, it also can be useful just to reverse a list. Shuffle is to reordinate the list in a random way. Again, remember that it is not actually shuffling a list. It is giving a new list with items shuffled. Sort is clearly what you can expect. Sort a list. And finally, sort by. You can pass it a function so that it to be used to sort. So if you can, for instance, here I have a list composed of lists of 2 elements, and I want to sort this according to the character of the first. So in the alphabetic order, say this could be a dictionary essentially. So strings and or associative arrays, strings and numbers, or numbers and numbers, what you want. And you want to say to sort alphabetically this according to the first string. So you can take X and Y are assigned the 2 lists. You take first the item 0 of the first, the item 0 of the second, you compare them, and then at the end you have the list sorted by alphabetically, essentially. Then I think that maybe I should add other. I should add n values in this list that it was not here, but it is important. N values, it is a way of creating a list. The other way is a list. I shall add these two maybe just now. So n values takes a number and a reporter, and you can it executes the reporter for this number of times, and concatenates the results in a list. So for instance, if you put here just a constant, you have a list of constant. If you, for instance, use this identity, you have a list of values. If you put here, say, some other command, you have a list of, say, other commands, for instance, a list of squares, or you can put here, for instance, a list, random so random float something, and you have a list of random numbers or something like this. I have not, now I remember, I have not put this here because it is not in the same in the same spirit of this, because it does not take a list and manipulates the list, it creates a list. So for instance, let's try with to test 2. Let n 10, let my list n values n, and then here I put x into, I don't know, for instance, random float, show my list, show this, and random float 1. Okay, so test 2, it gives me a list of random numbers, or okay, in this way I can build up some other say construction. Another way to build a list, clearly, if you want a list of constant, you can just write this in this way. But in generally, you want, say, a list of some variables. For instance, like this, say let A3, let B4. This might be produced in some other part of the codes. Let C, I don't know, green. And now I want to build up a list of ABC. I cannot just say let my list ABC. This is not working. But you have to use the operator list, and this is working. So the test, I don't remember, test 4, okay. You see that it is actually producing a list of variables, of things that are defined, not generally not here, but maybe, say, the result of some button, some piece of code, and so on. Okay, clear? I uploaded. This is important because NetLogo actually is a kind of Lisp, kind of a list manipulating program, and clearly one has to keep this in mind. The other aspect, the important aspect, are that beyond the list there are agent sets. Agent sets are something like a list, but they are not ordered. So, for instance, if you make, say, show patches, I don't know how many patches are here, because maybe we can just start a new. So show patches, it gives you a list of patches. So let me try to say create turtles, say 5, set xy random xcore random y core, create turtles. Okay, so in this way I create, say, 5 turtles. No? Then turtles is a set of our titles. So it is an agent set. So essentially, agent sets are not listed explicitly because they are not ordered. But I can ask the size of this agent set, no, length, not length, count, some agent set, so it returns 5. Essentially, we have 5 turtles. I may sometimes, the problem is that, so I can also one off this, but every time I ask for a one-off, clearly it returns a random sample, clearly one-off. This is exactly the same one-off of a list. So it is the same operator in this case. But if now I try to sort an agent set, it is sorted by, if they are turtles, by their ID. And if I try to sort the patches, they are sorted according to their coordinates. So starting from one corner to the other one. Now, for instance, now with the sort, this is a turtle. So for instance, I can apply some map. So for instance, x color of x, and so in this no, not patches, sort turtles. So I sort the turtles, and then with map I apply to each of them the operation give me the color of x. So I have the color of the patches. So if I, for instance, inspect of the turtle, instead turtle, say 1, which is this, I should see that the turtle 1 has color equal to 15, which is this one. Okay. So essentially, this is interesting. Clearly, it also has its limitations because not all, say, operation of agent set are, say, possible. For instance, I have not found a way of, say, making the intersection or the union of two agent sets. I don't see any union or intersection here. So the way is to convert the agent set into a list, then you can add the list, eventually removing duplicates, and then you have a list which is the union of two lists, and so on. Okay. So I think that this is enough for today. Clearly, I again ask you if you have questions, or if you want to propose some project for the last lesson, because I would like to end with some project. Clearly, if you don't propose anything, I can show you how to make a multiplayer game, how to make a more than one people work on the same project, maybe using the racing tool that we started developing. But so let me know, okay? And don't remember to register on on the form. Don't wait the last lesson to register. So, questions, comments? Are you still here?
Yeah, still here. Yeah, we are. We are still here.
You know, one in these online courses, one has always the suspect that everybody is sleeping or maybe doing other things. Okay, so don't be shy. Please send me suggestions, ideas, so that I can prepare the last lessons with something that may be of your interest. Okay.
Thank you for.
Okay, thank you.
See
Okay,
you.
thank you.
Thank you.
Bye. Thank you.
Bye.
Goodbye.
Thank you. Bye.